Hello guys, my name is Andy Pujo, and in this video I will be talking about the installation and the maintenance of the gesture recognition portion of the American Sign Language training system with gesture recognition version 1.1 version 1.0 project for spring of 2019. The product owner of this project is Francisco R. Ortega, and my team members are Joseph Medina, Sienna Rogers, Jason Garcia, and Lucio Salazar. The instructor for this class is Dr. Masoud Sajjadi. So for the installation and the maintenance of this part of the project, you will need the following things. You will need to install Python 3.5, preferably with Anaconda, because that will give you the ability of creating a virtual environment where all the dependencies, all the libraries, all the packages could be installed without messing anything in your actual system. So also TensorFlow, definitely that is the framework that is used for the gesture recognition at this point. You will need either the CPU version or the GPU version, preferably the GPU, but because it's more powerful and it's faster while training. However, if you don't have the if you don't have the an NVIDIA GPU, then you will have to use the CPU version. So if you do have a compatible NVIDIA GPU, fairly powerful GPU, go for the GPU version. If you don't, then go for the CPU version. So other things that you need is some Python libraries, which I will talk about later. You need the label IMG software, which will be used to label each image and to indicate where each of the objects that you want TensorFlow to recognize are within the image. And of course, the repository where the version 1.0 of the project is located. So, without further ado, let's just jump into it. So you will see that in this repository, this is the repository that contains the tutorial that I use personally uh, in order to do this project. Everything that you need is within here, but I will follow along with you, and I will guide you through this README. So first of all, the first thing you will see in here, the first step that you will see is that you need to install TensorFlow GPU 1.5, and for that you can go here to this link. This link will be in the description. Sorry about that. Let me install. So this link will be in the description. So in here you will see that if you already have Python, which you can also install through this link right here, which will also be in the description, then what you can do is just use pip, which is the package manager for Python, in order to install TensorFlow GPU. You should install the latest version, the latest stable version, not the alpha versions. So, for example, you will see that this in here has the TensorFlow 2.0 alpha. Don't install that. Install the regular stable version that TensorFlow provides for you. So for the Python, um, I recommend Python 3.0, 3.5, but you can go with a higher version of Python if you'd like. I believe it shouldn't have any issues, but the best compatibility is with Python 3.5 in my experience with this. So in here, just choose whichever installer is good for you. I recommend the .exe installer, the executable. So for example, in your case would be, if you're Windows, use this installer. If you are Mac, use these right here. So these are going to guide you through the installation of Python. And once you have Python installed, I believe that in here it will prompt you to install Anaconda with the Python version. But if it doesn't prompt you to install Anaconda, then you can go to this website right here, which I will provide the link in the description, and you can download the version of Anaconda and install it for that Python, so that you can use the Anaconda prompt to create the virtual environment and do everything in there. So I think that is the most out of the basic things. Let's start with here. So assuming that you have TensorFlow GPU installed, and assuming that you have already Python and Anaconda installed, let's just skip to this point right here, setting up the Anaconda virtual environment. So what I'm going to do is I'm going to come here to Anaconda and open the Anaconda prompt. You will see this is just a prompt right here, and what this will do is, what we'll do in here is copy this, and we will paste it in here. Oops. Let's see, Control C. Huh. Let me see something. Anaconda. Okay. So it appears that I have a problem with my version of Anaconda, but the idea is that you follow these. So in here, if you type this command right here, what this will do is it will create your version, your virtual environment, which is going to be called TensorFlow 1, and it's going to install Python 3.5 in that environment right there. So after that, what you would need to do is to activate TensorFlow 1. Once you've activated this virtual environment, then you can start installing everything else. So in here, what you will do is install TensorFlow GPU using pip, using this command that will install TensorFlow GPU for you. You can then install the Protobuf for Anaconda, and then these will be the Python libraries that you will need installed for the gesture recognition to work in your computer. You would need Pelo, LXML, Python, Jupyter, Matplotlib, Pandas, and OpenCV. These two right here, as are noted, are Pandas and OpenCV are not needed by TensorFlow. However, they are needed in the Python scripts to generate TF records and also to use the webcam feeds, which is what I use for the gesture recognition. The webcam picks up the image, which is then feed it into TensorFlow, and that is how TensorFlow analyzes the images and produces the output that I needed to produce. So you definitely need everything in here. So you see that once you've activated TensorFlow 1, there is going to be this TensorFlow 1 between parentheses before the actual path of the command line. So in my case, it is not showing up. For some reason, it is showing up just the regular command prompt, not the Anaconda prompt. But in my case, what I did was I actually used my computer. I actually installed everything in my computer, not in a virtual environment. However, it is more recommended for you to install it in a virtual environment so that you don't mess anything in your computer for other projects that you may have to do in the future. So after that, what you need to do is configure the Python path environment variable. This right here is a command that will add the TensorFlow models, folder where everything is contained. It will add it to your path so that you can execute things in the command line from anywhere. So, for example, if I want to train something from another uh, directory, I can probably do that using the Python path, because I have made these paths available to the computer in a global scale. So this, you can see, these are absolute paths, so it will be different most of the time for you. So what you need to do is you need to go to wherever you cloned the repository, and you will need to go to the folder that is named TensorFlow Models, which should be in the root. Once you are in the TensorFlow Models folder, there is another folder called Models, and that is the first path that you would need to copy for this right here. This, you see the models. After that, you would need to go one step deeper into research, and that is the second path that you will need, as you can see right here. And then the other path that you would need is in here for slim. So you would need also this right here. That right there will give you the third path that you need to set up for this part. So after that, you need to compile the Protobufs. So after you've done this, you can basically compile the Protobufs inside of the inside of this folder right here. So for example, in the object detection, you can see in here the TensorFlow object detection, where everything happens, is inside TensorFlow models, research, object detection. This is the folder that you will be working with. This is everything that you need. Everything else is off limits. Actually, even stuff in this folder is off limits. The only folders that you need to interact with are data, images, the inference graph, and training. Those are the only ones that you need to touch. Everything else is off limits. If you mess with any one of these folders, except for example, the faster CNN and the SSD inception, these are just models that can be used. You can erase it, you can do anything with it, but the other folders, do not touch it, because they have valuable and important scripts and files that are needed by TensorFlow in order to function properly. If you mess with any one of those and you accidentally erase it or accidentally do anything to it, be aware that this might not work anymore for you. So be careful with what you do. So if you come in here, you can see that there are a bunch of Python scripts. The only Python script that you will be modifying probably will be the object detection ASL.py. This is where everything happens, and this is what you will execute if you want this to work. For example, you want to run the program, this is where the models are loaded, where the images are captured. Everything happens in here. Now, there are other important scripts like the XML to CSV, the train.py, the export inference graph, and generate TF records. Those are the the ones that you're going to be working with the most, because you need to do those. You need to use those in order to train the model. Now, let's go back. In here, you can see that there are a bunch of protos in the folder. There are a bunch of protos right here. Well, these protos have been compiled, if I am not mistaken. So if I believe you can skip this step right here because it doesn't need to happen. However, still run it anyways, because it might be different for your computer or something like that, so that uh so that you don't run into any issues. Finally, what you need to do is just install, let's just say, the TensorFlow Object Detection API into your machine, and you will do these with these two commands. So what you need to do is come into the research right here, and you will see the research. So it would be in the TensorFlow models research, and you will see this setup.py right here. What you need to do is run the command prompt or whatever terminal you use, and run these two. So the Python setup.py, build and install. What this will do is build the TensorFlow object detection API in here, and then install it in your machine. So after you've done that, this is basically a verification to see if it works. If you have installed Jupyter, you can use Jupyter Notebook to open this file right here, which is provided to you by TensorFlow. So in here, if you look, there's this folder, this file, right here, which can be used to see if TensorFlow works. What this will do is open the Jupyter Notebook for you, and it will load. If you run every single part of this, it should run the script, and it should load images for you, with for example, this dog right here, and it should recognize that this right here is a dog and this right here is a dog, and there are other pictures that it should recognize as well. I think there's one with people and a kite and stuff like that, which it should be able to recognize. This is just a test to see whether everything that you've done until this point is correct, and that you can actually use the object detection API for the gesture recognition. However, if you just want to do the following, what you can do is you can come into object detection, and you can do Python object detection ASL.py, and that will run the you can see the webcam. It's going to run everything, and it will open a window for you. Well, you will see the webcam feed, and if you do anything, for example, if you show it a hand, it will be able to detect whatever it is. For example, in this case is an A. If I show this is a B, if I show this is a C, and so on and so forth, and you can see that everything is printing within the console, and it's also saving a file that is read by the Unreal Engine in order to do the verification and for the lessons to work. So now let's see what else. So after that, what you want to do is, that is basically everything for the installation. That is everything for the installation. Now, the maintenance, let's just go into the maintenance part of this. So what you would need for this is this right here, this software, which is done. You have it in here, but I already have it open. So for example, you can download it off of here, or you can just go into the GitHub and clone this right here. I will put this in the description so that you have access to it more easily. However, you can also come into this tutorial and just download it through here. So what you can do, I will also leave a video. This video right here shows you how to label and annotate images, and this is what you will need to do in order to train your model, your TensorFlow model. That is crucial for the training. If you don't do it, then TensorFlow is not going to gain any information from the images. So what you want to do is look at this video, and I do not have the software running in my machine. I deleted it and I tried to install it again, but it had some issues that I couldn't mitigate in time. So right now I am just giving you this video so that you can look at it. I will post this link in the description as well so that you have this video and that you can. But the basic idea of this is, you can see there's a picture in here. You can load images. If you can load a single image, or you can load a directory of images. If you load a directory of images, you can see that in here there's a list of all the images that are in that particular directory. So it will load up the image for you right here, and what you will do is, there's this button right here which says create rec box. What that will do is allow you to create a rectangle type thing around the object that you wish that the model would recognize. In this case, these are cards, right? So the model has to be able to recognize that this is an ace, this is a king, this is a 9, and this is an ace. So you can see that in here there's a rec box for an ace, and this rec box will have a label of ace. This right here will also have a label of ace. This has a label of king, and this has a label of 9. So once you create the rec box, a prompt will open for you, and you will be able to enter whichever label you want for your desired object. So for example, if I want to label a gesture, what I did was I took a picture of a hand, I drew a rec box around the hand, and I labeled it accordingly to the gesture that it corresponded to. So that, once you've done that, you can press save right here, and what that will do is it will save an XML file with the information and coordinates of each object inside of the image, so that you can then convert it into a readable format for TensorFlow in conjunction with the images, so that TensorFlow can know where it needs to look, basically, to see the object. So for example, it knows that it needs to recognize these types of objects as an ace, and it needs to recognize these as a king, and this is a 9, for example. It needs to be able to recognize those in particular for this example that is provided in here in this. This is not necessary. So for the training, what you would need to do is, you can see that there is, so what you want to do is just take a bunch of images. In my case, the images are here. You can see that they're split into two single folders. There's one test and one train folder. The test folder contains about 20% of the data set, and the train contains about 80% of the data set. And you will see in here that I have the picture and the XML file corresponding to that picture, and they have the same name. I have a bunch of pictures in here. So what you want to do, if you want to continue developing this, expanding upon this, for example, what you want to do is you want to gather more data sets. So for example, images of a word or something like that, and you want to use this specific format. It doesn't have to be named this this way, but it does help if you have it like this. For example, if you have the letter or the word and whatever number it corresponds to, so that so that it's easier to label. So once you've generated the XML files, right? You want to split everything. Like I said, drop 80% of the data set into the training and drop about 20% into the test right here. So if you have, let's say, 300 images, that would be roughly around, let's just say 50, 60 images. I believe 60 images, like 20% of the of 300. So what you would need to do is you would need to have 60 images, drop it in here, and then 60 images, and then 240 images into train. So after that, remember also that if you can use a variety of lighting conditions, distances, if the image is blurred, if the image has objects in front of it, that would be better. The more variety it has, the better it is for the model to recognize and to adapt to certain situations. So just keep that in mind. It doesn't necessarily have to be that way, but for example, if you see here, these are look at the hands of the A. You see that the lighting condition change, the distances are not the same, and so in that, that helps a little bit for the model to recognize in different conditions, so that it's just it's just more versatile. So once you've done that, drop it inside of this image folder, and what you will use is this XML to CSV file right here, Python script, in order to basically generate or convert all the XML files within the images folder. Every XML file that is either in the training and in the sorry about that, in the training and in the test folders, it will be converted into CSV, and it will be saved into this data folder right here. You can see that in here I have a CSV file with everything. It has the width, the height of the images, the file names, and where the objects are, each of them. It'll convert it into a CSV, and then that CSV will be converted into a TF record, this right here, using this generate TF record file right here. For your convenience, I have done a text file compiling a bunch of the commands that you need in order to train, in order to do certain other things. So for example, if you want to do the XML, what you want to do is just do CSV and do Python XML to CSV.py, and then that should run the script, and it should generate the two files, the test and the train CSV files, and you will see that you will have two outputs in here that says successfully converted the test or the train in there, and then you should see everything in this data right here. It takes a little bit of time. Give it time. See, successfully converted XML to CSV, and then for the train, you see that this right here, the train was generated right now, and then now here, this was also generated right now. So once that's done, once it's done and these are generated, what you want to do is use the generate TF record in order to generate the TF record, right? So there are two right here. Use these commands for that. There is one for the train, there is one for the test. If you copy and paste the first one, just copy and paste the first one. This is the train. Let's just do the test because it takes less time. So in here, just do that. Oops, sorry. These right here, TRecord CSV input. It should be right here, data. Actually, I believe, there you go. This, you don't have to get it from the website. You can get it straight from here and it should work. This is the test right here. Sorry about that. I knew I had it in there, but just in case, you can do that. This has the correct path for the project. So once that's done, it should generate the TF record. Let's see, let's go to data. Right here, you see this test data right here is now 0 kilobytes. Well, once it's done, it should be filled with stuff. See, successfully created TF records, blah, blah, blah. And now it has 20 megabytes worth of data right here. And you can do the same thing for the training. The training is going to take longer. You can then do this right here, this command, in order to generate the TF record. Once you've done the TF records, once you've generated the TF records, what you want to do is use the train.py right here. For that, what you need to do is use this right here. It's Python train.py, this flag, and then you need to specify the training there, and you need to specify the pipeline config path. Now, for the purpose of this video, or not this video, for this project, I have used this faster RCNN Inception v2 Coco model, which has slower recognition but higher accuracy. You could also use other models and you can experiment with other models, but I have found that this is the most effective one of them in recognizing everything. So if you go into the training folder, which is where the training is going to happen, you can see there's a bunch of stuff in here. You have a checkpoint, you have some events right here, and you have a bunch of checkpoints for the model. These right here are the steps of the training. So for example, if I run the training right now, the model will start the training at step 124,122 because there's a checkpoint at step 124,921. So if you want to start from scratch, you can just delete everything in here except for the config files of the faster RCNN and the MobileNet pets. Those you need. Do not delete those. I believe you can also delete the pipeline config, but do not delete the faster SCNN Inception. You need that file in order to train. If you go here, you can see that this is the pipeline that we are using. It's in training faster SCNN conceptions v2 pets.config. This is the configuration file for the training, and it will tell the training everything that it needs to know, where everything else and the configuration that it has for this specific training. So in here, you will see a bunch of things. This is an XML type file. The only things that you need to touch in here are this num classes, this checkpoint, and the input path, label path, a label map path, and these two right here, and the number of examples, I believe. So what the num classes does is it tells the model how many objects are being trained. So in my case, it was the 26 letters of the alphabet, so I labeled it 26. If you were expanding it, for example, if you're adding another letter or a number of a digit, for example, if you're adding the number 0, you would change it to 27 because now you have one more. And here, this right here is the checkpoint that you are going to be using for the pre-trained model. This right here is the path for this. So for example, you can see in here, I have the faster CNN inception Coco. This is what I'm using. I'm using the frozen inference graph.pb. Actually, no. I'm using model.ckpt right here, right? This is right here. If you want to use the mobile net, then you need to change this path into the SSD mobile net Coco right here, model ck.ckpt. I don't recommend it, but you can use different models. Now, I do have, there's this website right here that it has all the models that are provided by TensorFlow. You can use and experiment with these. It doesn't matter which one you use. You know, I used the one that was recommended in here, and it actually worked quite well. So, you know, if you want to use something else, you can definitely download any other of these, put it into here, and then use it for the training. There's no problem with that. But do be aware that the architecture of the model that you're using is the one that's going to be present in your model. Just be aware of that. Also, be aware that this is an absolute path. This is not going to be the same for you. So be careful. If it doesn't work, if you forget to actually change this to the correct path, then and it gives you an error, go and check this because it might be the case that you didn't change the path. Do change the path of this. This location is not going to be the same for you. You won't have this folder in your drive, most likely. So just go and change this particular path right here, and also change this particular path right here. So all these. So let me explain what these are. This right here is the location of the train TRecord that we generated earlier. You can see it's in data TRecord. You can go in here. This is the path that you need to set up. You need to set up this path and then train that record. And then this in here is the same thing, but with the test.record, right? Now this right here, this tells the model how many test images are within the images folder. Sorry, the test folder right here. Sorry, the images. So in here, there are roughly 1,630 images right here. The images, not the XML files. You can see that there's like 3,259. But there are roughly 1,630 images in total in the test. If you add more, you should change the number to whatever the increased amount now is. Also, for here you will see that there's this thing that's called object detection.pvtxt. This is a label map. If you look at here, this right here is this right here is something that, oh, actually, I forgot about this. So in the TRecord, generate TRecord.py, and here you will see this right here. This is something that you need in order to train your model. If you want to add something else, for example, if you add the number 0, you will do the following. You will need to add it, in here, with a different ID. So for example, what you would need to do is elif row label is equal to, and now look at this. This has to be the same label that you gave in the label IMG software. So whatever you labeled the object as in here, that is what you should place in here. So for example, if you just named it 0, then just name it 0 in there. And what you want to do is return, for example, in this case, 27. What this will do is whenever it sees a 0, it will return a 27, and for that you will need also this thing right here called object detection.pvtxt. What this will do is this will assign an ID to each gesture, and it will give it a name. So for example, in here you can see that I have an item which is ID number 1, and it has the name to be displayed is an A. So whenever it sees the ID 1, it should display an A. And you know, if it sees ID 2, it should be a B, and that needs to correspond to the label, to the TRecord, right? So for example, the A needs to be a 1, the B needs to be a 2, C needs to be a 3. So whatever you label this right here, also label it in the object detection PVTXT. So for example, in your case, if you are adding the 0, so what you want to do, actually it already has a 0. So in here, what you would need to do is just, you know, have this gesture 0 right here. This will be ID 27, which we added, and we said it will be ID 27, and it will be like that too in here. So you would need to add this new item with the gesture name. You know, the gesture name doesn't have to be anything, but you know, it doesn't have to be, it has to be unique, but you know, you can follow the same structure, and then give it the display name in order for the TensorFlow to draw the bounding box that you saw around my hand, and to label it accordingly to you know, to this. I mean, no, I don't want to save any of those. So let me see, am I missing something for the training? Yes, I am. So once you've started training, you will see something like this. You will see, if it starts correctly and you start seeing steps, it will give you this loss right here value. This loss for the particular model that I am training, that I'm using, which is the faster RCNN Inception V2, you need to leave it until it reaches consistently 0.05. It will start high. It will start at a 3, at a 5, or whatever, and it will drop down as more training occurs. You need to leave it until it reaches 0.05 of you know, value, in order for it to have the correct amount of training. So once you've done that, then you can just interrupt the training, and you will see that you will have inside of this training right here, you will see all these checkpoints. What you want to do then is use the export, you want to use the export inference graph.py script, which will allow you to export this inference graph into here, which is your newly trained model, right? So in here, what you want to do is you want to, and again, this is within here. You can see that in here I have this right here. You can just do this, copy and paste in here. And what you need to do is just change the x's the x's right here, you would need to change by the number, the highest number of the checkpoints. So in this case, it will be 124,121. That is what I would have to put in here. So it would be 124,921, and then you hit enter, and that should export the inference graph right here. If you already have an inference graph and you need to re-export it, you need to delete this folder and then re-export it. Okay? So what this will do is just generate this, and this frozen inference graph.pv is your newly trained model. So you will see that in the object detection ASL right here, this is the file that you would most likely need to work with. And you can see in here I have a bunch of this is mostly provided by TensorFlow, but I did some modifications to it. For example, the video capture and some other things. But everything else is basically, just leave it like it is. So if you can see here, the main thing is that I'm just using a video capture. This right here, this 0, if you were not familiar with CV2, this tells the computer which webcam are you using. In my case, I have only one webcam, which is the native webcam of my laptop. If you had an external webcam connected, which maybe you do, you would need to change it to a 1. Right? If your computer has more than one and you want to use the second one, you need to change it to a 1 or to a 2 or to a 3, whatever it is that the number of the webcam that you need to use. This is just setting the image value to 800 by 600, and then in here I'm just importing the path to CKPT. This is basically the model name, inference graph / frozen inference graph.pv. This is the name of the file, and this here right here is the path to the label map. Right here you can see num of classes, again the number of objects to detect. If you add more, you need to increase this number, and here I just have it at 26 because we only are detecting 26 images. This you don't have to touch. This you don't have to touch. You don't have to touch anything in here. This is all done by TensorFlow. And in here, this is basically just running through every single object that is generated by TensorFlow. And it is putting them all into a list if the accuracy is more than 50%. So for example, if the accuracy is 51%, it adds it to a list, and if there's only one object, it basically opens a file, prediction.csv, which is this file right here, and you can see it here. I have all 76%. So what this is doing basically is that it's opening a file. It has the name of whatever key right here, right? So in here it would be the O. This would be the key name, and then the prediction, which would be the string that I'm saving. That would be the key name O, for example, followed by a space, followed by a string of the integer of the value. The value right here would be the accuracy. You can see you saw that in the image. It was a 55% or a 90 something percent. Well, that 90 something percent is given to me by a value right here in decimal format, which I then just multiply by 100 so that it gives me this nice 76% instead of being 0.76, for example. So I just multiply by 100 and round it to the latest integer value and add a percent at the top, and then just write whatever that prediction is to the CSV file and then print the prediction. I have this in a try except cat clause, so that if something goes wrong, the program doesn't crash. And this right here is basically going through, if there are more than one object, then I am just running through every single object in the dictionary, and the one that has the higher accuracy is the one that gets saved into here. So that is basically everything out of the TensorFlow. Um, once you have your uh, your training and everything done, you should be able to use the object detection ASL script in order to use it. You can start, like I said, this part didn't involve a lot of code. I just modified the Python script a little bit, but you can try other things. If you want to use another model, another API, that is your prerogative. If you want to do anything else with this object detection API, now you know how. Remember, the steps are listed within here for the training. If you follow this, you should be good. However, you can also refer to this video again so that you have a more visual, uh, you know, a more visual, step by step. Let's just say like that. I should note there is also, let me see, there's also a YouTube video right here that you can watch, and this right here is basically the tutorial. So that is also another option that you have. It is within this tutorial. So if you have any questions, you can also comment here. There is also a section of some common errors that you might encounter. You refer to these if you need to. If you don't, then good for you. You can start using the object detection API for the next iteration of the project. So if you have any questions, please contact us at these emails right here. If you have any questions regarding this video, feel free, please. And if you have any questions about the project, you can also contact the instructor of the class, Dr. Sajjadi, at this email. Thank you very much for your time, for your attention, and hopefully this video was helpful and helped you guide through the installation and maintenance of the gesture recognition portion, machine learning portion of the American Sign Language training system with gesture recognition version 1.0 project. Thank you very much.